Okay, to talk about the exterior angle sum theorem, let's first review what we already know about triangles. We know that the sum of the interior angles is 180. So if I add all the interior angle measurements, I get 180. We also know that the interior and exterior angle right here, the linear pair, the ones that make the linear pair, are going to add up to 180 as well. Okay, so let me start by defining exterior angle actually. An exterior angle, that is the definition. It's the angle that makes a linear pair with your interior angle. Okay, so we've already learned these two theorems in earlier units or lessons. So now I'm going to show you the new one. The exterior angle sum, the 180s are the same. Here's the equal sign. The angles are lined up. So you might notice that the only thing different between these two is here I've got measurement angle 1 plus measurement angle 2, and here I've got measurement angle 4. And so what that tells me is that something plus angle 3 is 180, something plus angle 3 is 180. So what do I know about these two? I know that they must be the same. And that's actually the exterior angle theorem. The exterior angle, which is angle 4, is equal to the sum of the two remote interior angles. Like if I send you to a remote island, that means far away. So remote is the non-adjacent. That's what remote means. So not angle 3, but the other two. Okay? So a lot of times students like to stick with the first two because they're more comfortable with it, but there are times where this is going to be your best method. So if you learn it, it is an extra tool for your bag of tricks here. Okay, so let's look at a couple examples. So the first one is a situation where if I wanted to use one of the first two that I learned in earlier lessons, I could. For example, I could use the exterior angle theorem. Here's angle P. Okay, that's my exterior angle. Well, remember, my exterior angle is equal to the sum of the two remote interior angles. Remember, sum means plus. So, if I take the exterior angle, it's going to be equal to the sum of the two remote interior angles, the ones that are far away. Okay, and I get, let's see, 6, 7, 8, 9, 106 degrees. All right, so that's a quick and easy way to find it. Now, a lot of students, they might forget this new one, in which case you can still do this by using our old theorems. I could find this one first. So if I add 37 and 69, okay, I don't have a calculator, so I was double checking my math too. If I add those and then I subtract from 180, that's going to find my interior angle, right? So 180 minus 106 is 74. But then look at the math I'm going to do. Now I've got a linear pair, so I'm going to go right back to 180 minus 74, and that's going to get me right back to 106. So P is 106. So you see there's like 3 steps to do it to find P if you don't know the exterior angle theorem, the new one. Okay? But if you know the exterior angle theorem, it's a lot faster. Okay, on this one, you really have to know your exterior angle theorem. You have to, because, well, I say that, you could do 180 minus this for this angle, but the distribution gets a little tricky. The better way to do this is use your exterior angle theorem. Your exterior angle, so here's your exterior angle, is equal to the sum of the two remote interior angles, this one and this one. So I'm going to add the two remote interior angles and it's going to give me the exterior angle. My exterior angle 9n plus 8, that's the extra angle, is equal to the sum of the two remote interangles. So add these two together. I didn't leave a lot of room there, so I'm going to put 76 plus 3n minus 2. And of course the order of how you add those two isn't going to matter. Okay, so as I'm solving, I'm going to put 76 minus 2, that's 74. I like to combine like terms if possible first. And now I'm going to, I like to start with looking at my variable term and make sure that I'm subtracting or moving the smaller one. If I move the smaller one, I keep things positive. So that's 6n plus 8 equals 74. And then I'm running out of room here. I'm going to subtract 8. So I'm running out of room. That's 6n equals 66, sorry. All right, and then divide by 6. And I'm going to get n equals 11. Now listen, my directions said find the value of the variables, so I'm technically done, but what I'd like to do at this point is go back and substitute and make sure that this is going to make sense. So 3 times 11, 33 minus 2 gives me 31 degrees for this angle. And then over here, 9 times 11, 99 plus 8 is going to give me 107 degrees here. Now I can do, if I know my extra angle theorem, which I guess I have to do this, right? I can just add those and make sure they add up to 107. 6, 7, 7, 8, so that's 107, so yeah, that's good. So when I add those two angles, it equals 107. But again, I can check this by finding this angle and make sure that those make a linear pair. 31 and 76, that's 107. And if I do, let's see, 31 plus 76, 107. And then if I do 180 minus 107, I get 73. So that means this angle is 73. And now looking at these two, 73 plus 107 is 180. So I feel really confident about my answer here in this 11. All right, great. Now you can try a couple practice problems.